My screen is visible or not?
Yeah, it is visible, sir.
Okay.
Yeah.
Right. So thank you, sir, for inviting me for delivering this uh, talk in your FDP. Regarding this, I am thankful to Dr. Shivapujan Jayaswal. He has invited me, and I am also thankful to the host who have introduced me, and I am thankful to all audience who are here to listen this talk. So let me start my talk. The topic of the talk is role of demand side management in smart cities. As the topic of this FDP is energy management in smart cities. So I thought that the how an electrical engineer can contribute in smart cities. So the demand side management is one of the part of that. So I thought that this topic will be suitable for this FDP. Although my introduction was already given by the host, still I'm Dr. Vikas Singh Bhadoria. I'm working as Associate Professor in Electrical and Electronics Department, ABS Engineering College, Ghaziabad. And my complete presentation, I'm not going to discuss any results. This is the theoretical presentation, mainly the what are the main components of smart city, how DSM can contribute in a smart city, and in the last one slide is related to the research scope. I think whenever someone is listening such type of FVP or they are participating in online webinar, then there should be some outcome, and that outcome may be in the form of that they can take away some key points from that presentation or that talk, that what will be the future area of research that can go ahead in that particular direction. So this presentation is divided first the smart city, then the introduction about the DSM, what are the different DSM techniques that can be used, and then one slide is related to the research scope. So first is what is a smart city? As you can see clearly that I have mentioned this a smart as at the rate. This is intentionally. This at the rate is intentionally because in a smart city, the maximum communication will be through the internet. Have you ever assumed about the thought about the smartphone? Before smart city, let us think about a smartphone. What are the features that a smartphone include? Suppose whenever we are considering a difference between basic phone and smartphone, then basic phone is having a feature of just calling and sending a text message. Then whenever we move from a basic phone towards a smartphone, then some features was added in that. Those features maybe WhatsApp, Facebook, video calling, internet browsing, and several others. Now the features of any smartphone changes or as per the requirement of the user. User selects the smartphone as per their requirement. Suppose someone is having a hobby of photography, then he will prefer a smartphone which is having a higher resolution camera. If somebody is having the hobby of playing game, then he will prefer more RAM. So the selection about the smartphone depends on the type of use by the customer. Similarly, the definition of the smart city are different as per the requirement of the resident of that particular city. So that's why there is no particular definition. Specific definition is available still I will give some definition. This one is the smart city uses the information and communication technology, means use of ICT tool is must in smart cities, and this use of ICT technology will be for the purpose of increase in operational efficiency, means the efficiency should be increased, and then sharing the information, that information should be shared within with the public, and the purpose of the sharing information and the use of ICT tool will be for the purpose of the quality improvement in the quality of government service, and this improvement will be for the purpose of citizen welfare. So this is the one definition of a smart city. Another definition, that a smart city is a framework. In this framework, again they will use the ICT technologies, and the use of ICT technology will be for the development purpose, for deployment purpose, and this development and deployment, this will be for the purpose of promoting sustainable development practices, means to increase the comfort level of residents, to improve the facilities whatever the residents in that particular city are residing, and this will be with the help of the ICT technologies. So the ICT technology is the key parameter in smart city, and later we will also discuss some other parameters. So then smart city is an intelligent network, because we are using ICT tools, so it is an intelligent network, and ICT tools are used intelligent. We are saying that it is an intelligent network. So for intelligence purpose, all objects and machines should be interconnected. This interconnection may be wired or that may be wireless. So whenever we are able to communicate between the machines, between the devices, only in that case we can say that that particular network is intelligent. For this communication purpose, we need IoT application devices, and for storing that large amount of data, these cloud-based IoT applications are used, and the data which we are receiving from different devices with the help of sensors, that data will help to the stakeholders for making better decisions, and these decisions will be made for the improvement in quality of life. So that's why I have mentioned that use of ICT tool is must, because several devices has to be connected with each other, and sensors will be used to sense the data, and that data will be communicated from device to the decision maker, and again decision maker to the devices. So one example may be that this process can be used for the improvement in energy distribution. One example may be. Then another example may be to the streamline the trash collection, the waste. Whenever the dustbin will full, then that smart dustbin will send a message to the trash collection team. Then they will visit and collect that trash. Then decreasing the traffic congestion, this may be one of the use, increasing the air quality, and ultimately these all the applications will be held through the use of ICT devices, or we can say that use of IoT. Now consider some examples. Suppose one example, let us think for some time, that one example is that traffic lights are connected. All traffic lights are connected, and they receive data from sensors. These sensors are placed on the cars. Whenever any traffic light will sense that in a particular route the number of cars are more, then those lights will sense in real time, and the red light time will be less and green light time will be more. So this will reduce the road congestion. This may be the one example of the smart city where data can communicate from the car to the particular red light. Another example may be the connected car can communicate with parking meters. That electric vehicle, this is going to be this will be the main parameter which will help in increasing the smartness in a smart city or increasing the use of electricity in smart cities. Then one example that I have already mentioned, that smart garbage scans, they will automatically send data to waste management companies, and then waste management company will come and pick up that waste. This will be a scheduled pickup. Otherwise, what will happen, that there is a pre-planned visit that waste collection company will visit once a day or twice a day. Uh, in this case, when a smart garbage collector or a smart dustbins are there, then the waste collecting company will visit only when the dustbin will send a message to the waste collecting company. One more example, that citizen smartphone. The smartphone maybe the driver's license. The all administrative officers or the administration of a city can track that person is moving at which location, whether he has jumped the red light or whether that person is driving at over speed. So all this data can be accessed only when the cities are or the different objects in the smart cities are interconnected through ICT devices. And as I have already mentioned, that sensors are the must for this purpose, because first part is to sense that particular event. And for making any city smart by collecting different data, urban planners will develop a plan or an ecosystem for making a smart city. And for this purpose, they will consider the four main points, that the four major stakeholders. One is institutional, another one the physical, social, and economic infrastructure. These infrastructures will be kept in mind while deciding a plan for any smart city. And as this I have mentioned in the example of the phone, that initially the phone was used for the purpose of only calling and sending a text message. Then later on, features were added. A small camera was added in the backside, then selfie camera was added, then the flashlight was added in that. So this smartness increases in terms of layers. So in the case of smart cities also, this smartness can be added in terms of layers. Initially, one level of smartness can be added, and after that, later on, slowly, other smart features can be added in smart cities. So these are the main components of a smart city. One is smart manufacturing, then smart government. This smart manufacturing is, suppose a company is having an information that the demand of particular product is rising or decreasing. Accordingly, they will produce that particular product. So this will be resulting in the saving of cost of that manufacturing company. Then mobility, Wi-Fi, smart and digital citizens. Digital citizens means our health system data is completely recorded and it is stored on a cloud. So whenever we are feeling any problem, health related problem, we will wristband, that smart watches are coming, or Fitbit fitness bands are there. Whenever they will sense any abnormality in our health, they will send a signal to the doctor, and automatically doctor will send those that prescription to a nearby medical store, and from that medical store a delivery person will come with the medicines prescribed by the doctor. So this will be a smart system which can be implemented through use of the ICT devices. And then data, smart health that I have mentioned, then smart farming or smart agriculture. This agriculture, that irrigation, if we are able to sense that how much water is required or which chemical is required or which particular component is required for the better production of the crop, then this will help in the saving of our energy. Then smart building, this is another key component. In smart building, we are able to sense the light energy, temperature, humidity, and as per those parameters, the lighting, uh, the illumination level of particular lights, those smart lights that will be set, and that will save in the saving the energy consumption. Then smart grid, smart transportation. We are all already using the Ola and Uber apps. In those apps, we are able to track that the what is the location of your cab. The driver is able to locate that you are at which place. So this is the one example of smart transportation. Later on, features can be added in this, and the smart city structure or infrastructure will be more energy saving and having more comfort. So the essential technologies of a smart city. One is smart transportation. This smart transportation, I have mentioned one example of Ola or Uber. Another example we can take that suppose we are residing or our residence is in the nearby areas where some offices are located, and there is some parking space which is at our residence, and if somebody is coming to the office, that person is facing the problem of car parking. If smart transportation is there, then if I am outside our residence, I will send a signal to the server that my parking location is vacant. Whenever someone is visiting to the office which is located nearby my residence, he or she can use that parking space. Suppose I am having electric vehicle charging point also, then that person will come, and he is or she is having electric vehicle, then that person can come and charge his or her electric vehicle also. So this can be done through the data only. When I am able to communicate and the person who want to use, he or she is able to access that data. So that's why the another point is the smart data. That data has to be stored at some particular location, as mentioned in the previous slides, that the cloud, and that data should be accessible for all. That I am able to send and somebody is able to access that. Although some security issues might be in this case, that has to be taken care, but the data should be accessible for all. Then smart infrastructure. This is another key technology which is required for the smart cities. And smart mobility. Smart mobility means the data transfer from one point to another point, or from one user to another user. This should be proper and fast. There should not be any data loss, as we are already facing in some webinars that some participants or sometimes some speakers connects and disconnects. This is the issue of network. So, and data transfer is not proper. So smart mobility means data transfer should be proper from one end to another end. Then for all these purpose, the main point is smart IoT devices. These will be helping in the communication between the devices which are connected in any smart city. Then smart energy. Smart energy is the In this, the different components are there, like we can say that smart grid is there, smart meters are there. The consumers are able to change their demand patterns when some devices are suggesting, or some utility companies are able to suggest that if you are shifting your load from this duration to this duration, that is the part of the discussion of upcoming slides, that the demand side management. So there are several features related to the smart energy. So these are the essential technologies in smart city. The core infrastructure that smart city is having, these are the expectation that a smart city should have these facilities. One is the adequate water supply, that water supply should be sufficient. Then the electricity supply should also be sufficient. As an electrical engineer, I am more worried about this electrical supply. Then sanitization or solid waste management, civil engineers may be interested in this. Then efficient urban mobility and public transport, electric vehicle, that will be the key part of this. Then affordable housing, that building energy management, that is the upcoming topic of discussion after this talk. So that will, that is also a part of smart city. And several other parts are there. Good governance, like in the nowadays in the COVID-19 situation, we are able to see that in Delhi government has launched an application, that Delhi Corona, we are able to track that which hospital is having how many beds and how many ventilators available for the corona patients. So good governance is also a part of that smart city. Health and education, so there are several expectations that a smart city should have. Now the smart solution for these desired objectives, one is e-governance, this e-governance. Then energy management will include smart meter, use of renewable energy, energy efficient and green buildings. Then, as I have already mentioned, the example of parking and the traffic management system. Another example may be the telemedicine or teleeducation, skill development centers. So there are different smart solutions for the problems existing in the current cities. If we are able to implement these solutions, then only we can say that now this city is smart. And these smart solutions are as per the Indian expectation. This figure or these smart solutions are taken from this slide. So this is the website of smart cities for the India. So smart meter may be one of them. The wastewater treatment, waste handling. There are several others. One of them is this video crime. We can consider this video crime, that suppose CCTV cameras are installed in the city. Whenever they are detecting any crime, they will send a signal to nearby police stations, and then police station will send a signal to nearby PCR, and then PCR will reach immediately at that particular crime location. Nowadays, those cameras are able to record, but they are not able to take any decision. They can record, but if that they will be able to take a decision, then that will be a smart solution. Now, the different benefit of a smart cities, that transportation enhanced, citizens, the infrastructure will be improved, traffic awareness will be improved. In traffic awareness, we can consider one more example. Suppose we are having information of train. That train is running how many minutes late, or is it on time, then it will reduce our waiting time at the platforms. So that is smart, because we are able to track the Ola or Uber cab. Nowadays, although train tracking system is available, but if we will make that more efficient, then it will reduce the time of public time, that waiting time that the person used to spend at any particular platform or at any railway station. So waste management system will reduce the environment footprint, water efficiency will increase, that video camera feature which I have discussed, that will increase the security, the overall economic development will be there, revenue generation will be there. So there are different benefits of the smart cities. Then this, the people, cities, energy, and technology is the key parameter for connecting these three. As I have mentioned that I will be discussing the demand side management. So demand side management, this will be managing the energy with the help of, or managing the electrical energy with the help of technology. So technology plays a key role in smart cities. Although the people are there, but technology is the must use of ICT tool, Internet of Things. These will play the main roles. So use of technology and making a city smarter. That will be the electrical energy. So how a smart city works, this is the main point, that we have discussed the different features of a smart city. The feature, the working of any smart city, that first they will collect data. So data is the main part for the functioning of a smart city. And for this data collection purpose, we need sensors. Different type of sensors will be located in that city, different objects. Then that data will be collected with the help of those sensors. Then that data will be analyzed. After analyzing that data, some communication will be done. That as I have mentioned, that suppose video camera is able to capture that some crime is happening at particular place, then they will analyze that data, and then that system will be able to send a communication to nearby police station. So then police station will send a signal to PCR. So communication, then action. The communication is done to police station, then after that, then action has been taken to send a PCR to that particular crime location. So these are the four main steps. That first is collect data, then analyze that data, then communicate, and then action has to be taken for that. Now the smart grid is the main component of the smart city, because in a smart city, each and every object should be smart. Smart means that should be able to communicate, that should be able to take decision. So a smart grid should be smart from both sides, means supply side as well as from demand side. Generally, in the power supply or the system in which we are using the electricity, that is smarter from the supply side. But in the smart cities, it should be smarter from the demand side also. And how it will be smarter, this will be discussed in the upcoming slide. So this is the supply side of management. There are two terms, supply side management and another is demand side management. In supply side, this supply side management is the traditional approach. In this, utility company will collect some resources, then they will prepare those resources. After that, using those resources, electricity generation will be done. Then after the generation, that electricity or electrical power will be transmitted, then the primary distribution, and ultimately it will be used by the end user. So this is the traditional approach of supply side management. In this is the case. This is the case of India, that if the frequency is 50 hertz, this frequency will be for 50 hertz. If the generation and demand both are equal, then this frequency is 50 hertz and the grid is balanced. But if due to any reason there is mismatch in demand and generation, suppose generation is less and demand is high, so what will happen? that frequency will be decreasing from the 50 hertz. If this frequency is decreasing, means there is unbalanced in the grid. So this unbalancing can result in load shedding. And whenever load shedding occurs, this is the human tendency that if there is any power cut, then we will look into the neighbor's house that whether this power cut is in my house only or it is for the complete society. If it is for complete society, then okay. If it is in my house only, then I have to check that whether it is the fault or when any MCB is tripped or there is any other reason. So the consumer's behavior during load shedding is, if it is for the complete society, then they will sit and wait that let the power come. So they will they will suffer silently and helplessly. They will say nothing. They will wait for the power that whenever it will come, then again they will start using that power. Or sometimes if the power cut is more, then what they will say that this is expensive for the middle class and out of reach for the poorer section. And then after that, still the power cut is more, then those who can purchase, they will purchase either diesel generators or they will purchase inverters for their individual use. But these diesel generators or inverters, these will be able to cater a part of light load only. You can't run AC on inverter. You can run lighting load or fan load. So for the AC purpose, you need proper power supply, and you are not able to run refrigerators or even water pumps or AC with the help of inverters. Second, if inverters are used, then they are energy guzzlers. Why this word is written? Because they consume nearly twice energy to charge their batteries. Once the batteries are used, then the power consumed in charging those batteries will be twice of that. And another main point with those batteries is that they will increase the losses due to harmonics. So inverters are not friendly to the power, or they are not beneficial. Then this is the supply side management approach. Every time supply side management will try to improve the supply delivery, they will try to increase the supply capacity, but all these should be with the decrease in supply cost, because this has to be done with decrease in supply cost. Whenever a consumer is purchasing electricity, and if they are increasing the price, then some opposition will be there that why the prices are increased, etc., etc. So every time any supply side is interested that they can improve the delivery of the supply, they can increase the capacity, but these two works will be done with the reduction in supply cost, but it is not possible at all times. So what are the concern of supply sides? The main concern of supply sides are that how can they keep price low, because the land price is increasing, another fuel cost is increasing, environment compliance cost is increasing, operational and maintenance cost is increasing. And if so many factors are increasing, then how can they keep the cost low? This is the main concern of supply side companies. That's why DSM or active participation of customers are required. Only supply side management will not be effective for the reduction in cost. Supply side role is also required, and how that supply side role is helpful, that I will discuss in upcoming slides. So this is the typical all India demand curve. We can see in this curve that this is the minimum demand and this is the maximum demand. So there is difference between minimum and maximum demand, and that maximum demand is, this is maximum duration, this demand is less than 130 gigawatt. Although this is the old data, but for the maximum duration, this demand is less than 130 gigawatt, and for very short duration it is more than 130 gigawatt. And to fulfill this data, to fulfill this demand, the utilities has to install extra generators, and that will cost extra for the utility companies. So if somehow this extra power demand can be shifted to any other place, then utilities will not have any requirement for installing any extra generating capacity. This power can be, if by any method, this can be shifted to here, or this can be shifted to here, because it is this in this duration the usage of power is very less. So if this will be shifted, then this will results in the saving of utility companies. They will they need not to install any extra generators. Now how this can be achieved? So there are different methodologies. Consider one example, that there is one bulb of 100 watt, and this 100-watt bulb runs for 10 hours. Then the total power consumption will be 1 unit or 1 kilowatt hour. Again, consider the 100-watt bulbs and the number of bulbs are 10. So again, this power will be 1000 watt, and if these 10 bulbs will run for 1 hour, then power consumption will be 1 kilowatt hour. In both the cases, if this is case 1 and this is case 2, in both the cases the power consumption is 1 kilowatt hour, but in the second case the power demand is 10 times more as compared to case 1. This one is having less demand and this one is having more demand. If we are able to distribute this demand for 10 hours, then the energy consumption will be less, demand will be less, and the generating cost or the extra generator installment cost will not be required. So this will be helping in saving in cost of utility companies. So this will be done with the help of customers. So now the demand side management comes into picture, and for the demand side management, any action, this the definition we can say that any action which is beyond the point of supply, means this is not controlled by the supply. They have the generating capacity, and this action has to be done beyond the point of supply, and this action will try to change the amount or timing. They can change the amount of consumption or timing of consumption where at the customer's use. Means customer is changing their consumption pattern, or the customer is changing the time of use, then that will help in reduction in cost. So then some standard definitions of demand side management, that as per the IEEE, demand side management encompasses the entire range of management function. So this is the management, demand side management is the management function associated with the direct demand side activities. Means this is related to the demand side, then the program related to demand side may be the planning, evaluation, implementation, and monitoring. First they need to plan, then they need to evaluate, then implement, and after implementation the continuous monitoring is required whether it is beneficial or not. So this is the standard definition by the IEEE terminology. Then according to US Department of Energy, the action taken on the customer side, not on the utility side. It is action on customer side to change the amount or timing. The main points or key points are that it should be done at the customer side, and it should change the amount of consumption or time of use. So, and then the objective of this will be the maximizing end use efficiency to avoid or postpone the construction of new generating plants, because if the maximum demand will be shorter duration although, but the utility company has to install new generating plants. If somehow we are able to shift that time, then this may avoid or this may postpone the installation of new generating plants. So this definition is by the US Department of Energy. Then as per the Indian agency, that Bureau of Energy Efficiency, that demand side management is used to describe the actions of a utility beyond the customer's meter. It means at the customer side, with the objective of altering the end use of electricity. Means we are again modifying the use pattern. This may be for the increase in demand, decrease in demand, shifting. This can be done between high and low peak periods. So this is the standard definition by the BEE. Now from these definitions we can summarize that it is demand side management. It is a mechanism to influence customers' capability. Point which we need to focus, that it is capability, and second is willingness. First thing is that customer is capable to change their his or her demand pattern. This is the main point. And second point, he is able to change, but he is not willing to change. So that point is also kept in mind while implementing the demand side management, that whether customer is able and whether he or she is willing to change their demand pattern or not. Because sometimes it may be there that critical and non-critical load concept is used in the demands whenever we are implementing the demand side management, that the critical loads are connected in that particular duration, then customer may not be willing to change his or her demand pattern. So the customer is capable and he is willing to change. Now in this case, whenever he is capable and willing, in that case utilities program to fine tune customers' energy consumption pattern. This is demand side management. And for this another point, that utility can control and manage the demand. This control and management will be within the limitations of the availability of resources. Means that within the minimum and the maximum demand. So for this purpose, the manipulation can be done for the load. This manipulation will be done to manage peak load and off peak load, and this can be done with the help of demand side management. So the main concept of demand side management to reduce the peak energy demand, one thing, or to shift the time use, time of use, and this shifting will be done towards the off peak time, as I have mentioned in the duck shape curve or Indian demand pattern. And for this purpose, different activities can be done, the programs can be run, some tactics can be used. Tactics are this activities, program or tactics, maybe some financial incentives can be done, that if you are shifting your load from peak load to low demand period, then some incentives will be given to the customers. Some public awareness program can be launched, that if you are using demand side management, that it is beneficial for you as well as for the utilities. Educational program can be launched for this purpose to create awareness of demand side management. Then it is a point which need to be noted that peak demand management does not necessarily change the total energy consumption. As I have mentioned in the bulb example, that the total energy consumption is 1 kilowatt. So it does not change the total energy consumption. Total energy consumption will remain same, but still it can reduce the cost of new investment, or it can avoid the cost of new investment. For this purpose, the new energy storage units can be used, and these storage units can be charged during load demand, and that those can be discharged in the duration of peak demand. Due to this reason, this demand side management is also known as energy demand management. This is the main point, that scientific control, this shifting, reducing, or avoiding or time of use, this all has to be done with the help of scientific control. Means it should not be done in the random manner. For this purpose, proper demand side management techniques has to be implemented, evaluated. Only then that DSM can be implemented. Or if DSM is implemented by the scientific control only, then that will be beneficial. If we are applying this in a random way, then sometimes it may be beneficial, or sometimes it may not be beneficial. So to perform demand side management, these are the main activities: that energy efficiency, energy conservation, and load management. So how to perform this demand side management? So the main activities that has to be performed, one is load management program. So one word is written, that redistribute, means the power, the demand which is in the duration of peak, that can be shifted towards the duration where the demand is less. So redistribution of demand can be done in the load management program. Second is conservation program. Conservation program means reduce energy use. In this reduction of energy use, so energy efficient buildings can play an important role. Improvement or use of energy efficient devices can be done, like in the lighting system, the maximum lighting systems are replaced by LEDs, so that those LEDs help in the energy conservation. And then next is the strategic load growth program. In this energy increased energy use, this can be done in sometimes, whenever this can be decided, as I mentioned in the previous, that this growth can be decided by some scientific control. So strategic load growth program can also be used for the demand side management purpose. Now these are the main activities or the main programs of the demand side management. One is energy efficiency, demand response, and strategic load growth. Then demand response is also divided into two parts. One is market based program, another one is reliability based program. And in the reliability, the interruptible load, direct load control, or emergency program. And similarly, market based is divided into two: demand bidding and real time. And real time is divided into real time rate, critical peak rate, and time of use rate. So whenever we are applying any demand side management, then any out of these, any of the method or any of the approach can be used for applying demand side management. Then the strategies used in demand side management, these are the 6 main strategies. One is energy conservation. We can say clearly this arrow is showing downward, means it will reduce the demand. Now the aim, the what is the aim of this strategy? Second, what is its impact on peak demand, and then what is its impact on energy demand. So in the energy conservation, we are reducing energy, so it will reduce the overall energy demand. If overall energy demand is reduced, so peak will reduce and energy demand will also reduce. If we are clipping a peak, means for this duration to this duration, in the peak time we are clipping the load, we are disconnecting the load for this duration, then this will reduce the load. So the impact on peak demand will decrease, and impact of energy demand, that will also decrease. Now next is load shifting. In this, we are shifting this load from this point to this point, or from this point to this point. So peak load will decrease, but the energy demand will not decrease, because we are shifting that demand from one point to, or one duration to another duration. Then flexible reliability. In this also, this will reduce the peak demand, because we are shifting the load as per the choice. And if this may connect or disconnect, so impact of energy demand, this energy demand may reduce. Then strategic load growth. In this, it is the opposite of energy conservation, so the peak demand will increase and energy demand will also increase. Now this is the valley filling. In this valley filling, we are connecting additional load in the low demand period. So the peak demand will remain unchanged, but the total energy demand will increase. So these are the 6 main strategies of the demand side management. Now the benefits of demand side management, these are divided into 4 parts. One is economic, technical, environmental, and market based. So economic, again, economic for the utility side and economic benefit towards the customer side. So first, or the main concern is the economic benefit, that extra capital cost, this can be avoided, efficiency will increase, postponing of new facilities, means that installation of new facility may be shifted. Then average losses will reduce, running cost will reduce, startup and shutdown cost reduction, because we are shifting the load from peak time to low demand period. So a generator which has to be operated to compensate that peak demand, that startup and shutdown cost will not be included in that. So low cost energy, and towards the customer side, bill cost will reduce, and efficient appliances can be used by the customers. Then some technical advantage, that there is reliability improvement, extended facility lifespan, improved power factor, and flexible maintenance performance. So there are several types that can be discussed one by one in any paper, or you can discuss that this reference also. This, each and every point is discussed in detail in this paper. Now the DSM initiatives taken by the Indian government. So one is the Energy Conservation Act. This was established in 2001. This governs the several policies regarding the demand side management initiatives. And second is the Bureau of Energy Efficiency, BEE, which we are little bit aware about BEE, that whenever we are going to purchase any electrical appliances, then we used to see the star rating. That star rating is provided by this BEE, that use 3 or 4 or 5 star ratings. So initiatives taken by the Bureau of Energy Efficiency. One is lighting DSM or Bachat Lamp Yojana. This is one of the scheme. Then the standard and labeling program, as I mentioned, that we generally prefer the 5-star rating appliances. Then some energy conservation building codes and energy efficiency in existing building program, means a star rating can be given to buildings also. Then star rating of building, then applying DSM in municipal and agriculture also. So these are the some Bureau of Energy Efficiency initiatives. Then DSM implementation in India. So one is first point for the DSM implementation is that assessment of current electricity market. Then forecast the load. First decide that what is the electricity market, what is the status of electricity market. Then after that, the forecasting of load, because if we are not forecasting the load, then the proper implementation of DSM cannot be done. Then after forecasting, perform load or market research. Then after this research, define the load shape objectives, that which one you want to apply. Then you need to identify the source of financing for the DSM, because it will include some cost. Then selection of program. After that, this cost benefit analysis, because the cost, without cost benefit analysis, any utility will not be interested in implementation of demand side management program. Because if we are applying any demand side management program, then customers as well as utility both should be smart, means bidirectional communication will be there. Bidirectional communication will be there, means sensors will be used, IoT devices will be used, and then again the complete process which we have already discussed in the smart cities, that collect data, analyze data, communication, and then action. These all 4 steps has to be done in demand side management also. So sensors will be required for the collection of data purpose. Then that data should be stored in some cloud. Then analysis of that data has to be done. So all these will require some additional cost. So who will finance this additional cost? And if any financer is financing, then what is the benefit to that financer? So that cost benefit analysis has to be done. And after that, what will be the impacts of that DSM? Impacts means the social impacts, economic impacts, and environmental impacts are also, these has to be considered during the analysis. Then how that DSM will be implemented, and after the implementation, don't leave that. Monitor and evaluate that DSM, that whether that DSM is performing satisfactorily or not. If that is not performing, then again we need to change that DSM plan as per the feedback received during the monitoring and evaluation purpose. Now the DSM programs running in India, India, USA, and the UK. This is the comparison. Then MI means majorly implemented, PI means partially implemented, and NI means not implemented. We can say that energy efficient motors. In India, we are able to see only one. This is most implemented, not majorly implemented, and this majorly implemented is CFL or LEDs. Otherwise, most programs are either partially implemented or not implemented. Compared to other countries, USA and UK, in USA, the mostly implemented, and only one DZ, this is not implemented. although this comparison is of the 2014. Maybe now they maybe switch to the distributed generation also, because now disease technologies are becoming popular day by day. So in the DSM programs, one is the energy efficient motors, then time of day, CFL or LEDs, high efficiency fan and pumps, power factor improvement devices in India partially implemented, and high efficiency fan and pumps. In fan and pumps, it is not implemented, but in AC we are following the guidelines that we are using the higher star rating appliances. Then peak demand reduction not implemented. Then advanced metering infrastructure, residential it is not implemented, but industrial it is implemented. In some areas in residential also now they are taking reading through the Wi-Fi devices. Initially, the meter reader has to visit door to door to collect the reading. Now they are collecting, taking the reading through Wi-Fi devices. The meter reader used to visit a particular area in a sector, or in that sector up to a certain range or up to a certain diameter, the devices connected at the residences or the meters connected at residences, that the reading can be taken through Wi-Fi devices which that meter reader is having. So as previously mentioned, that step by step or layer by layer smartness is being added in all existing devices. Now, what are the barriers in demand side management programs? If DSM is beneficial for all, it is beneficial for utilities, beneficial for customers, beneficial for environmental also, then what are the barriers? So one is the main, that distributions utilities perception. Utilities are having fear for loss of revenue. This is the main barrier. Now, this DSM is not directly related to the core business of electricity supply. They are not bothering about demand side management. They are thinking that their business is to generate and distribute. That's why it is mentioned in the implementation framework that cost benefit analysis has to be done. If that cost benefit analysis will be there, then the utilities will be more aware about the DSM programs. Then DSM is not mandated in any legal framework. Means the government should mention in guidelines that utility company has to implement DSM program. Otherwise, they will not be allowed to distribute. Some others, that utilities are not able to visualize the impact of DSM programs. One main point in this is customer acceptance also. And it was mentioned in the previous that customer is able to and he is willing to. So customers acceptance is also one of the barrier, that customer is not willing to change their use pattern unless and until he is having he is having the information about the benefit. Initially, we are a little bit hesitant about the shifting from normal bulbs to LEDs, but now the customers are aware and they are directly purchasing the LEDs. So some awareness program has to be done towards the awareness of DSM among the customers. If they will be properly aware, then their acceptance level will be little bit high. So what are the major stakeholders of demand side management? That state government should make a rule that each utility company has to follow the DSM. Then consumer has to change their demand pattern and they should be ready for that. Then R&D organization, they should do the proper R&D for the implementation of DSM, and they will be able to come up a proper DSM plan with the proper cost benefit analysis. Now media, this is also one of the major stakeholders, because media can raise the awareness among the consumers or among the public towards the DSM programs. Then electricity regulatory commissions, they will form the proper guidelines related to the DSM, the proper rules and regulations for implementation of DSM. Then manufacturers, it should be decided by the manufacturers that they will not produce a non-energy efficient device. If manufacturers will produce only energy efficient devices, then automatically the DSM one part of energy use of energy efficient equipments can be done. Utilities, they need to follow the DSM. Agencies, they will they need to promote the DSM programs by giving some incentive or proposing some plan to of incentive. Then financial agencies, these agencies should come forward to finance the demand side management programs, because implementation of any DSM program will require some finance, and that finance can be supported by some financing agencies. So now this is the last slide of my presentation, that what are the outcomes or what are the research areas in that we can conduct the research. One is, as it is already known to us, that the two types of research can be done. One is the component based and another one is the system based. So whenever we are doing research component based, and that in technology, if someone is interested in component based research, then he or she can prefer the technology based, that what are the advancement in smart meters, how those smart meters are communicating, what are the problems with the smart meters. These areas can be taken for the research purpose. How that direct load control switching can be done, distributed generation integration, what are the problems associated with distributed generation integration, which type of DC can be integrated, this can be one of the research area. Then demand response, this can be one of the research area. Then electric vehicle, this is the upcoming thrust area in the research, that how electric vehicles will be connected with the grid, how these electric vehicles will be charged, what are the problems associated with the electric vehicle charging, what are the problems with electric vehicle batteries, battery management system, vehicle to grid, grid to vehicle integration. So there are several areas in the technologies in which the research can be done. Then if someone is interested in the policy field, then they can perform a case study, that how a tariff or incentive policy is affecting any DSM program. Then if program, any awareness or information program which is being run by any agency, that may be from the newspaper or from the BEE, what is the effect of that awareness campaign on the behavior of the consumers or the users, that can be one of the research topic. Or how that information or awareness campaign affected the buying pattern or installing the energy efficient appliances. This can be one of the research area. This management persons can do the research in this. And the customer and utility driven, means market driven research. If somebody want to perform the market driven research, then this may be another research area. So to sum up my presentation, that for making a city smart, we need to follow one small part of that smart city, that is demand side management. And for the implementation of demand side management, utility and the consumer both has to come forward, and every consumer should act like a prosumer, and the consumer or prosumer is expected that they should not tower their power. uh, this is that's all from the my side. And now any questions from anybody? Hello.
Yes, sir. It was a
So
wonderful.
that's all from my side.
Thank you, sir. Thanks a lot. That was a wonderful session. But I have one, two questions. The first one is from Professor Nirvan Chakraborty. He's asking, time of the tariff is comes under deregulated electricity market, and in India, where it is being used now.
So 1 minute. Actually, I am not able to listen properly. If let me check
Yeah,
if
I'll
the
repeat.
question is.
I'll repeat. I'll
Let
repeat.
let me check if the question is in the chat box.
It is
So
there in the chat box, sir.
uh, the time of day tariff is comes under the deregulated electricity market in India, where it is used now. Actually, I'm not properly aware that in India where it is implemented, because maximum uh, in the maximum power system, the uniform tariff is followed. Uniform tariff means the time of day is not preferred, but if it is being used at any location, so I am not aware at right now regarding that.
Okay. Another question is from Professor Subhashish Majhi. He's asking that how do you manage the solid waste management smartly?
Sir, solid waste management, although it is related to the civil engineering, but one thing which any electrical engineer can contribute in that, that we can make a smart dustbin or a smart waste segregation method can be done, in which whenever any waste material is put kept inside a dustbin, then on the basis of their dielectric strength, waste material segregation can be done. So this may be one of the aspect of any electrical engineer, or otherwise I think the civil person will answer it in a better way.
That's it, sir. Thanks a lot. Thank you very much for your presentation and for taking time out for our FDP. I hope that our participants has learned a lot of things about the contribution of your topic in smart city. I thank on behalf of the university and the organizers you yet again. Thank you very much.
Thank you, sir. Thank you for the Sharda University, and thanks for all the participants. They were here for throughout the session. And thank you one and all who is involved directly or indirectly in this FDP, and all the organizers who have called me for this session. Thank you. Thanks a lot, sir.
Thank you, sir. Thank you. Dear participants, our next speaker is Professor Chitra Chidambaram. She is a professor in architecture and planning, Sharda University, Greater Noida. Professor Chitra Chidambaram is an architect planner, having completed her B.Arch from Bangalore University with a gold medal and masters in infrastructural planning from University of Stuttgart, Germany. She has worked as a research consultant to several national and international organizations, including HUDCO, FICCI, UNDP, etc. She has worked as principal investigator on many construction-driven research projects of Department of Science and Technology, Government of India. She has organized and conducted field projects as part of NGO. She has also served as business line manager for Builder certification over 5 years for a multinational certification body, ICMQ India. She has conducted training programs for building professionals under MNRE scheme. She has over 28 years of experience, and she is an accredited professional in India Green Building Congress. I heartily welcome Professor Chitra Chidambaram to address the session.
Thank you so much. And thanks for the nice introduction. Am I audible?
Yes, ma'am, you are audible.
Okay. So is the screen visible?
It is, yes, it is visible, ma'am. You can go to full screen mode.
Yeah, we do that.
Yeah. It's all good, ma'am.
Yeah, thank you. Thank you so much.
Welcome, ma'am.
So good afternoon. In fact, from the demand side management, what was handled by the previous speaker, at the smart city level, I am taking you down to the building level. And as an architect, the perspective is also very much from how to manage through good design and through conservation measures, as well as, of course, management of performance becomes very important, and that we would handle at the end of the topic. So to start with, the title itself, Energy Conservation and Management, is what I would build on, but all the same, it is energy management in buildings. And why buildings are very important, why do we have to manage energy in buildings, is primarily because buildings consume over 40% of world's energy. So, and much of this is going to be in cities, and it is expected that it may rise up to 60% in the coming years. So it has to be, we cannot ignore the building level energy management when we are talking of the management of the role of management at city level. So the other thing is also the environmental impact. So one is the consumption of energy as a resource, and the second is the implication on the environment. And it is through one of the publications listed here, it's about 75% of global carbon dioxide is emitted because of the energy usage, both during the construction and the operational life of buildings. So this is enormous impact, and therefore cities have to make their buildings energy smart, which would mean efficient, green, and sustainable. In today's presentation, I'll take you through some introduction on energy management in buildings, then what is building design energy management, then energy consumption in buildings, again refer to the ECBC code, which was referred to by the previous speaker, and talk about energy criteria in sustainable building before I propose a building energy management model. So we start with what is energy management in buildings. Energy management in buildings is defined as the process of planning, guiding, and controlling energy supply and consumption to maximize productivity and comfort and minimize energy costs and environmental pollution. So it's very, very clear what exactly is the purpose of energy management, and the objectives are listed out. First is to reduce energy costs. Second, to optimize energy consumption, manage occupant comfort, buildings have to be comfortable, enhance occupants' productivity, so people have to be functioning at their best, create energy independence. We also want to see if we can work towards net zero buildings eventually, minimize environmental impact of energy services. So this is again a very important concept for sustainable buildings. So all of these come under the objectives for building energy management. How do we approach this is mainly first of all through conservation. In fact, the National Building Code puts energy conservation and management together when it handles management, because conservation is the first task that has to be done if we have to be effective in management. So conserve energy, and how do you do it? Through solar passive building design, sustainable materials. Then optimize utilization. This would be through enhanced efficiency measures, through control of active energy devices systems, and monitor their performance on site. This is very important. Of course, generate energy through renewable systems is an added important measure that we have to consider. And the basic principle for any management is what can be measured can be managed. We need to measure through meters, sub-meters at every level so that we can effectively manage. So the basic principle is what can be measured. So, and how do we do this? What are the enablers or facilitators for this? Is, of course, for anything to do with building, the National Building Code. And fortunately, all of these codes and guidelines have been from time to time revised. So they are trying to incorporate the need of the day into their guidelines, into their stipulations. So we can see the NBC 2016 brings a lot of energy conservation management into its domain. Energy Conservation Building Code, this of course is like a Bible when it comes to energy conservation. So I will detail the building code from the building perspective, although it was mentioned by the previous speaker as well. Then of course the labeling and the star rating scheme for equipments, which is again very important because we use a lot of equipments in our buildings. ECBC compliant building scheme, how buildings are rated through these ECBC compliance. And of course, the sustainable rating scheme of Griha, which is now the national rating scheme, that is the green rating for integrated habitat assessment, which is again 2019 revised. So we have the latest with us, which brings in the need of the day. It captures the need of the day so that we can effectively perform in this domain. And how do they provide this enabling tool is basically they assess the criteria, what is to be actually measured, what are the standard values, what are the indices, and the right benchmarks. Benchmarks for minimum requirement, benchmarks for doing better in enhancing benchmarks. So these are all set, and that is how they ensure that the buildings are performing at their best. So before we go into the details of management, I would like to take you through some building design, how energy has been integrated into building design, and not today, traditional buildings.
Sorry, ma'am, I'm stopping you for a moment.
Yeah.
Can you be a little bit louder, please?
Louder?
Yeah, please.
Okay.
Yeah, ma'am. Thank you.
Yeah. Is it better now?
It's all good, ma'am. It's all good.
It's good? Okay. So now I will take you through the energy in building design, how this has been integrated through the times. It is not today that we are getting aware of the importance of energy, but it has been through times, and traditional buildings were always integrated. It was energy conscious. The climate had been integrated into design, climate responsive architecture, what we call as. If you could see the Havelis, the Totti Manis of the South India, you can see that the walls were all much thicker. They were of a material which had very low thermal transmissivity. And they also had a lot of culture captured through their material, through their design. And these buildings were truly energy efficient. And later, of course, with the Industrial Revolution, there were the industries for cement and steel. And we, of course, came into the mode of a functional building, much more functional. And they, of course, incorporated some energy efficient components in their design. Like, for example, we did have chejjas, we did have ventilators, and we had courtyards. So this was there in the planning. So this was in the conventional buildings, which were in the early 1900s. But the problem came since 1980s. The modern building, when we started aping the West, when we started guzzling energy through our glass facades, and when we completely, dependent on HVAC systems, which in turn made our buildings gain so much heat from the outside. As a result, the entire system became very, very energy demanding. And this is when I think we realized that it is time to look back. We need to come back into some sort of an efficient design where capturing our vernacular systems, as well as the conventional systems, as well as the modern technologies. Together, we need to arrive at some more energy efficient ways of building. And the first, of course, came through the ECBC. In fact, the Energy Conservation Act was put forth in 2001. And under that, the Bureau of Energy Efficiency was set up, and which came up with this ECBC code, Energy Conservation Building Code. And this has been more or less like a Bible for energy conservation. And in fact, Griha or most of the sustainable schemes also dovetail the requirements of ECBC into its energy performing criteria. So the ECBC compliant design insisted upon insulating the walls, the roofs, and trying to have better kinds of glass, low emissivity glass, and it insisted upon shading devices, daylighting for buildings. So through these, there was a lot of efficiency that was incorporated into buildings. Of course, where we need to go in the future is the high performance buildings, which not only tries energy efficiency to build into our buildings, but also tries to generate electricity through smart technology. It would also try to integrate many more passive and low energy systems into its design. Plus, it would also try to integrate greens and bring the advantages of effective landscape into building. This is where we need to go in times to come. So now, what are the design parameters that we normally consider when we talk of energy efficiency in buildings? First of all is the external landscape. So the landscape modifies the building microclimate. The microclimate immediately surrounding the building in terms of the wind direction, in terms of shading. So this is very important that we use and maximize the benefit of landscape into our building design. And then comes the building orientation. Orientation of building, the form of the building is again very important with respect to the sun path, how you actually place your building, which are the facades that are exposed to maximum heat, and how we can avoid, how through design we can have buffering within for effective climate control in buildings. And the forms, what are the better forms? Do we have long buildings, small buildings, round buildings, tall buildings? So all of these are very effective. If you can use these, there are lots of research that has been done in built form, the surface area to the perimeter, the building volume to surface area, how we could actually use these to make an effective built form which can perform effectively in terms of energy performance. Then thermal properties of materials. This is again very important. The right type of materials can make a lot of difference in the performance, energy performance. If you have, for example, cavity wall, or if you have perforated walls, or you have walls which are made of much lighter, or even it could be adobe constructions. All of these have different kinds of material properties. So in our selection, we have to be very sensitive to how these materials perform energetically when we are talking of energy efficiency. And envelope and fenestration. Envelope is the outermost skin. This is the skin which will connect you to the outside. And this skin has to ensure that during the hot days, the heat is prevented from entering. And how we can have walls and roofs which ensure that it is cool in summers and tries to keep it warm during very cold winters. So the envelope and fenestration design, the design of windows, at what height, what kind of window, what is the size of the window, what is the type of glass, all of these are very important in our design for energy efficiency. And of course, passive strategies is something that is newly coming in a very big way through our sustainable buildings. And I will again take you through what is passive and how it can be integrated. And these specialized passive strategies, which could mean anywhere from using some kinds of fans and some low energy devices alongside, can effectively modify. In fact, through one of the case studies of an ECBC compliant, I will also explain how each of these strategies can make a change to the performance. And finally, the active systems. This is, of course, consumes energy. But if we are selective, if we know what are the energy efficient devices, systems, and how we could actually integrate all of these into our buildings, there can be an effective way of designing for more energetic performance of buildings. Now, to start with, how do we, or where do we exactly consume energy in buildings? This is a very basic slide of different end uses for lighting, water heating, HVAC, power, pumps, lifts. So we consume at for various end uses. And if you see, primarily, it is lighting, almost 1/3 in residential and 2/3 in commercial building. This is the average consumption that has been put forth by BE itself, that we have enormous lighting and HVAC in case of commercial. Equivalence is fans, for example. 1/3 is fans and 1/3 is light. This is the kind of end uses that we have. So if we can ensure that, first of all, our buildings are built so that they are energy efficient, and then try to integrate these components which are energy efficient, I think we will go a long way to reduce the energy consumption through buildings. And not only the energy consumption at the consumer end, because every unit that we save means that we save 2 units in the production. This is very important because we have a lot of distribution and losses alongside transmission and distribution losses. So it means almost 2 units, double is what is being produced for giving us half the amount of energy at the consuming end. And also in terms of pollution, we are reducing 2 units of flue gases. And this is enormous if we are trying to work towards environmental sustainability. So it is important that we not only work at our end itself, but we see it at the larger macroscopic advantages and try to be more efficient in our buildings. And it has been identified that the maximum saving potential is in new buildings, commercial new buildings. Although there has been significant reduction in terms of even residential existing buildings, you can, up to 20%, you can make modifications and you can save energy consumption. So now I'll go into the details of the Energy Conservation Building Code and what are the different requirements for this and how this can ensure that the efficient performance of buildings. And first of all, the scope is, originally it was 500 kilowatts when ECBC was first proposed in 2007, but now it has come down to 100 kilowatts. That means we are trying to ensure that even small building complexes are now more energy efficient. And there are different ways of trying to comply with this goal. So there is flexibility. There are different, today you have tools of simulation through which you can ensure that you have the optimum mix of the various envelope as well as the various strategies of devices and systems that you integrate into your building design that can make it more effective. So we have mandatory provisions. These are generally as per the ISO 15099. So it stipulates what should be the U factor. What should be the U factor is the thermal transmissivity factor. That means how much of the outside heat is actually transferred. We have to have a very low U factor that would be very efficient. Then what is the solar heat gain factor, quotient, which is SHGC? What percentage of the outside heat is actually transferred to the inside? And this is for all reflective components. For our glass, what should be the SHGC? So what is the good SHGC? And this is a very important criteria to manage, and these are mandates for the ECBC compliant buildings. And air leakage, because air brings heat along into the buildings. So how we could ensure that we have the right kind of air connections between the outside and the inside, and what should be the maximum leakage that is permitted so that we could have an energy efficient inside. Then prescriptive also, it also gives prescriptions in terms of what should be the U factor of the roof. And very clearly it says in which climate and for what kind of building. This is again a very important component that we should understand, that the performance depends on how many hours of the day. Is it a 24-hour building or is it a 8-hour or a 12-hour building? It also needs to be known whether it is working for a retail facility or is it a residential facility or an industrial facility. So the type of performance also varies with it, and acceptability also varies. So I think the prescriptive method puts very clearly the U factor, the R factor for various climatic zones. It says for composite zone, for thermal, for warm humid, for hot dry. It lists separate U factors, the resistivity factors, as well as the VLT. The VLT is also the visible light transmittance. This is again very important for the windows, for the glazing, because we need to know there is a basic inherent conflict. We need light, we need the daylight, but we don't need the heat. So we need to make sure that we have enough light to work so that we don't depend on artificial lighting. But at the same time, it should not be that it is bringing in too much heat into the insides. So there has been a very good balance that is worked. What we call as window wall ratio has been stipulated. What should be the maximum window wall ratio? So this is also stipulated in ECBC. So indirectly, much of the energy management is done through the code itself. So this is what I'm saying. So we need to adhere and comply by the code requirements for an effective energy management strategy in buildings. And they also give trade-off options. This is again important. Trade-off. What is trade-off? That means if you can't manage to have a very, very well-performing wall, then you can manage with a better roof. Or if roof and wall are not very good, then try to have a better glazing. So together, try for the envelope. Within the envelope, the various components, you try to trade off and you make it very energy efficient. And there is also whole building performance method. That means not only the building envelope, you can also integrate your lighting, your electrical power, your service water heating, or it could also mean HVAC. You can integrate all of these, and together you have to ensure energy efficiency. This is what is the requirement of the code. And I think it goes a long way in managing energy efficiency at building level. And in ECBC 2017, which is a very recent, they also recognize enhanced performance through ECBC Plus and ECBC Super Plus. So they give you scope for not just the minimum requirement, minimum compliance, but also enhance your performance through these recognitions of ECBC Plus and ECBC Super Plus. So now, once we have these various tools and guidelines, what is important? How is it actually measured? The building energy efficiency. That is through the EPI, what we call as the Energy Performance Index. This is the key for all comparisons, for all measuring how your energy building is performing in terms of energy. What is EPI? It's a very, very easily you can handle this index, because it is just the annual energy consumption of the entire facility divided by the total built up area in meters squared. So in kilowatt hour divided by meters squared per year. So this is EPI. So EPI gives you a very clear indication how your facility is performing in terms of energy. And of course, based on this, they also have star rating scheme. ECBC is the basis, and EPI is the measuring index. And with that, BEE has launched the star rating of existing buildings from 2009. And there is also what is called as an ECBC compliant building for new buildings, to ensure that every building tries to achieve the energy efficiency. I will take you through a very small case study, which is the Center for Science and Environment in IIT Kanpur. And this is one of the first buildings which were evaluated as ECBC compliant, and subsequently, of course, even as Griha rated, 5-star rated building. So you can see that there are various interventions. So first of all, they set what is called as a base building, a building which without energy efficient measures that are stipulated by ECBC, but at the same time, they have the same structure, they have the same load, they have the same design. So on that building, they take a simulation and they understand what would be the U factor, what is the SHGC factor. They actually get all the measurements for a base building. And then they make for each of these interventions they propose. For example, the wall, I don't know whether it is visible because it's unfortunately a very small font here. So a 230 mm brickwork wall was replaced by 2115. That means it is the same, but you have a cavity in between with some insulation. And you can see with that, the difference from U value of 1.985 watt per meter square Kelvin, it came down to U value was 0.59 watt. So there was a significant 1/3 just by the way of separating the building into two components with an insulation layer. And similarly, roof with some extra tiling and with some extra insulation, U value was brought down to 1/4. So similarly, this is how you can be effective in management. If you can actually measure for each component, what is going to be the change by a particular intervention, what will be the change in its different performing indices. For example, U or SHGC, for example, glass here, a single clear 6 mm glass would have some U value of 5.7. Whereas the same thing when you have double glazed, low emissivity, low E glass, it comes down to 1.6, which is again less than 1/3. So I think there is significant, today there are lots of materials in the market. There are lots of techniques. There are a lot of guidelines that are provided. So you just have to make the effort to build it right so that half the problem of management is solved in the design itself. And EPI, just through the building envelope measures, in fact, like this, they have all the interventions that are put forth, and then you can see very clearly, it's summarized. Just through building envelope optimization from what was energy performance index of 240 kilowatt hour, it came down to 208. Then further through lighting optimization, they used more of LED and CFLs instead of the conventional light bulbs. See what the difference is, 168 kilowatt hour. In fact, lighting has always been targeted as the first criteria for energy efficiency in buildings because they bring significant differences, and at the same time, they will not affect when it comes as much when it comes to, because we have what are called what is known as the lux level. So very easily the lux levels can be managed with using these energy efficient devices. For at the work plane, the illumination levels can be ensured, including the daylight component that has to be integrated into this. So lighting has been one of the first criteria that have been attempted for all certifications. And then HVAC, you further come down to 168, then through sensors and controls further. So like this, with every strategy, this is possible because we're metering every end use. This is how it can be an effective way of managing, that you meter every end use, and you will be able to know what is the difference it is making when you have this particular intervention. And at the end of it, what was 240 has come down to 98, which is almost less than I think it is 40% of the original. So if we can make so much difference, automatically the reliance on energy, and even if we are planning to now work towards net zero, if we are planning to actually generate energy, that means we need to, this is the kind of energy that is required, which is definitely possible. Yes. So I think this is where we need to work in the design itself for effective management. And payback, of course, at the end of it, everything comes to cost. Yes, all of these will cost. The first installment, initially it is going to be expensive, and it has been found that in about 5 to 7 years, we will break even the cost. And again, in 15 years now, when they see that it is almost, it's making profits of about 20%. So this is how you can effectively manage. It will be long-term. Much of the design, compliance measures would be little longer for actually payback, but at the same time, they are much more effective. And there is very little energy consumption in such strategies. Now we move into GRIHA. GRIHA is the Green Rating for Integrated Habitat Assessment, which I've already mentioned to you. And the latest manual is the 5th version. In the last 7-8 years, there have been 5 versions. So that means that all of these codes and standards and guidelines are trying to integrate and maximize. They are getting a lot of information from the ground, from the field, and trying to integrate into their design. So they are very effective, and we actually try to use them in our design and operation. And this 2019 insists not only on, it dovetails all the ECBC requirement. That means for its energy criteria, you have to ensure that the ECBC requirements are taken care of. So that has to be the first, they are mandatory. And beyond, they actually recognize. And almost about 30 points out of the 100 points are relevant to energy criteria. So that means it is very important that energy is a resource which people for sustainability has been identified as a key resource, even at the building level. Water, of course, today water is as important as energy, but both of these take almost 1/3 of the share and all the rest. And of course, there was one question related to solid waste management. So waste. So waste to energy is again something people should be talking about, because how waste is one thing that we are now getting more and more, and how we now try to convert them into resource is going to be the future for tomorrow for any level. It could be not just at the building level, but even at the city level, at the neighborhood level, at every level, how we can convert this into energy. Now, coming into the GRIHA criteria, of course, besides these ECBC criteria, what has already been illustrated before, I would like to emphasize that they integrate a lot of passive design strategies. So this is what I think is the strength that the building envelope can bring in, and the building design can bring in for energy efficiency. So there is a lot of, in the design itself, for example, we have airlocks, we have cross ventilation. This is something that I think from age-old times, we were always wanting to have cross ventilation. But there came a time when we said, no, we want everything conditioned. But now looking back and working back, it has been found that cross ventilation can be very effective especially in warm, humid climates. So I think for depending on the context, of course, everything today needs to relate to the context, but in the right context, these are very effective. That's why we have a whole lot of strategies that are available in the guidelines of Griha itself, that you can do it through, for example, solar chimney somewhere, trome wall somewhere, maybe in the cold climates, trome wall is a very effective strategy. So depending on that, and measuring for each of them may be very difficult. Therefore, we try to have this EPI. So making these, integrating into these, we are trying to find out what would be the difference in the EPI and how that could be effectively monitored. And there are also a lot of these low energy active design strategies that are proposed in Griha. For example, we have Earth Day Tunnel, of course, then which I think is now quite well known when it comes to a passive strategy. And this requires some amount of energy per se in some cases. So that's why it is included as a low energy strategy as well. And this uses the property that 4 meters below ground, there is almost uniform temperature through the entire year. So that means that if we can take our air 4 meters down and try to loop in there through coils and then bring it up, more or less the cooling is done. The earth is doing the cooling for you. So if this kind of efficiencies can be integrated into our building design, I think we are trying to reduce the dependence on the energy which is generating so much of greenhouse gases and flue gases which are harming our environment as well. So there are evaporative strategies, in fact, Mughals, for example, they were always using this kind of ponds around, the fountains around. Why? Because they can bring down the climate, the need for energy in the buildings through the variation in the microclimate itself, through bringing down the requirement, the cooling the environment itself. So there are, most of these are some form of energy, which is, some form of strategy, which is using envelope, which is using the environment, which is using the natural properties and trying to integrate some amount of energy so that it is effective as a low energy strategy for buildings. Of course, all equipments have to be, now today this is integrated into all our sustainable schemes, that it has to be star labeled, minimum 3-star labeled if you would like to have a point on it. So indirectly, we are using energy efficient devices. We are trying to build in our systems. We are trying to build the envelope, and together we ensure that we are having an energy efficient buildings. And today, of course, technology is something that's adding a big dimension into this entire gamut of various strategies. Specialized glazing. Today we have lots of different kinds of glazing. In fact, Saint-Gobain comes with every new day, it has a new thing to put forth. This type of glazing that we are talking of, for example, is spectrally selective. It will let the visible light come into a space that is from 300 to 700, the wavelength. It lets it, but it blocks the infrared and the ultraviolet. So indirectly, it blocks the heat coming in, but it permits the light. And thereby, it will bring daylight, but it will avoid heat. So there are very different kinds of glazing that is coming in today in the market. Smart windows. We have windows which are like our iris in the eyes, which open wide when there is less light outside and more or less constrict to a small pore when there is too much light outside. So it tries to balance. So we have the photochromatic smart windows today, which will check what is the light level outside, and accordingly, it aligns this thing so that whether the light will come in or get blocked. So indirectly, all of this is trying to ensure that every component of a building is working more efficiently through these smart technologies. External shading devices. Today, shading has become one of the major interventions that we are proposing into building. We had straight facades, glass facades, even 14-story, 20-story. But today we realize that we need to have devices to shade the walls, which can significantly bring down the energy, that is heat that is entering into our buildings. So these shading devices could be in the form of louvers, it could be in the form of awnings, it could be a variety. But at the same time, it can become an architectural feature itself. There are lots of beautiful materials that are aesthetically very pleasing that are coming into the market, trying to bring, and there are recycled materials, because in the context of sustainability, it is also that it has to be something from the waste. That is what I said, trying to use waste in our different components can make a significant, because if you are trying to use virgin raw materials, that means you are using energy from at some stage, maybe at the material extraction stage, at the material processing stage. So trying to avoid that, trying to build it into our final component as a recycled material is again a very important strategy. Then double skin building facades. Here again, you have 2 glass panels, but at the same time, you have some air in between. Air is an excellent insulator. So trying to build all of these components into our technology today, we are trying to get into building integrated photovoltaics. Photovoltaic is one of the very successful so far. I think it has been experimented a lot in the country, particularly our country where we have so much sun. And it has been found that it can be a very, very reliable source of energy as well. Renewable energy, one of the major limitations is that it is not a very reliable source. But if we can build in reliable sources, then it means that we can use renewable energy in a big way in many of our energy requirements. And building integrated where the facade takes the photovoltaic into it. That means the skin integrates the building, the photovoltaics into it, the components. So as a result, it also brings a very different kind of aesthetics, as well as it can also generate energy. And more and more kinds of modules, PV modules are coming in, which can actually get integrated. And of course, the building energy management systems is a very important component. That means real-time data you are getting. See, all of these are basically because of the development in the information technology. So today we have within the building, there are these small, it shows how the various components are behaving, where what is happening, and real-time data, which lets you actually manage. So these are tomorrow's technology. I think every building, every promising building, progressive building, I think needs to integrate these, research more, make them much more, not just as a sample or as a thing, but it has to become as a part of the routine building energy management itself. So now the Griha benchmark. So this is what I said. Ultimately, they're all trying to come up with very easy EPIs. This is how you can know where you perform or where you stand in terms of your energetic performance. For example, for various climatic zones, for various typology of building, and for various occupancy hours. So it gives what exactly is the kilowatt hour. And these are quite stringent because ECDC is stringent. In fact, if you check on the U factor and SHEC factor, it is not very easy to achieve them. But I think that is where is the challenge. How we could effectively, through our techniques, through our building techniques, because every context, every region in the country comes with a very rich vocabulary of building energy techniques. So I'm sure if that can be integrated in an effective manner, there could be ways of trying to ensure that all of these, we don't need only the insulations that are provided. There are insulations of, even in the vernacular medium, just the earthen pots, the inverted earthen pots were working very effectively in Rajasthan roofs. So I think they have to be much more research, even from the architectural perspectives, even from the, the building energy professionals who can actually try to understand how to come up with various ways of trying to reduce the energy consumption in buildings. And of course, generation is a new gamut, which is again very important. And there have been lots of challenges in this. There have been a lot of research, lot of promotion through building, through government, funding for research at various levels. In fact, for the last 25 years, people have been trying to do research on how to actually integrate energy generation into buildings. So there has been some promises of late, but still there is a long way to go. Hybrid systems are being integrated, but still it's a very marginal level. For example, 1% of total peak demand is all that is a mandatory requirement when it comes to Griha. So I think we need to have maybe 20%, 30%. Very soon we need to ensure that we are trying to be energy independent and try to generate energy within the building complex. So now, besides all of these, there are, one is the design aspect, the other one is how you actually manage the facility. Of course, there are, today there is a profession that is the energy auditors and managers. This is actually through an exam, people actually qualify and ensure that they have the required skills to ensure that not only the building, the initial startup, but how they are actually performing on site. They have to be actually evaluated. And this is very important for us to use these services to ensure that our equipments and our systems are performing as they are designed. We have lots of HVAC systems in the building, lots of lighting and electrical, even renewable energy. All of these require commissioning to ensure that they are as per the design. They should be validated for the performance on post installation. And then we need the smart metering, not just gross metering, but we need to have at every end use. This is very important for us to understand whether lighting, outdoor lighting is taking more, or indoor light, or where there is a scope for us to actually reduce the consumption, where we can enhance our efficiency. So for this, to identify the various kinds of this thing, and it is actually, through points, they are promoting that you have sub-metering at every type of energy consumption system or device that you have, for lifts, for common areas, for exit lights, for everything. You have a separate meter. So you know where you can actually reduce or where you can actually manage better. Energy audits. So I said this is a part of the requirement for every rating, for renewal of a certification of Griha or IGBC, you have to supply energy audit information. And this is quite exhaustive. It is not just overall how much you have saved, because ultimately energy audit is not just what you're consuming, but it also means how you're consuming, for what you're consuming, what kind of supply you are using for this, and also, if there is a continual improvement from last year, are you improving upon it this year? So that is also very important. And operation and maintenance in buildings is, of course, finally, buildings have to be operated and maintained smart. They have to be maintained such that preventive maintenance plans should be very, very well laid out. That automatically there are no repairs. Charges are becoming very less, and the records of maintenance should be very clear. So this is all actually a management system. Basically, you must have a facility group, you must have an inspection plan, how frequently they should be inspected, what are the kind of maintenance that should be done, and how they should be recorded. This is a protocol that has to be actually in every building site, as well as every system and equipment has to also be checked and maintained from time to time. Because safety is something that is also integrated into this. When we talk of sustainability, safety is also integrated. So we need to ensure that we may have a lot of devices and systems, but they should perform not only efficiently, but very safely. Safety is, again, have to be built into all of these. And this is, of course, based on the ISO. I've just put the 4 together. That is the PDCA cycle. That's the Plan, Do, Check, Act. So in every level, this can be done. Of course, this is done more at the organization level, but even at the building level. So we can have targets. What is the target? What should be the consumption target? What should be the demand target for energy? And what should be exactly how we design envelopes and devices and systems, and how they are actually built, commissioned, and how they are inspected, metered, monitored, and finally, what kind of interventions and optimization strategies we actually incorporate, so that it will feed back to the planning, so that we improve, we do better, we are in the same cycle, so that we are all the time on the continual improvement mode. And benefits, very clearly you can see the percentage reduction through, these are the IGBC rated buildings. So it's 40%, 45%, 63%. This is the kind of reduction we have. So I think definitely it calls for immediate and urgent action. And which means, of course, it's all in terms of saving in rupees. So you can see crores of rupees can be saved through effective management. And at the same time, buildings are built for comfort, built for effective functioning. So we need to have visual comfort. We need to be productive in buildings. So for which it shows that there's a percentage increase in productivity of 36% in most of these certified buildings, which means although they're energy efficient, they're performing effectively in terms of energy, of course, not just energy, in terms of water, in terms of waste management, in terms of various other things. But all the same, the productivity in these spaces there is a significant gain in productivity, and there is a satisfaction level of the end user, which is again very important. So these are some of the references I've used, and thank you. Thank you so much. And if there is any question, I would like to take them.
Thank you very much, ma'am. It was a very nice presentation, very enlightening, really. I have 1-2 questions in the chat box, ma'am. The question is from Professor Shubham Agarwal.
Okay.
He's saying that since we will be needing good analytics and data science inputs,
Yeah.
also raw materials, can you please comment on the supply and value chain of these emerging sectors?
Yes. See, this is, of course, a very important element of how to actually get the supply chain. For example, if you are familiar, there is what is called an FSI, that is Forest Stewardship, this thing for timber, for example. Right from the forest, they are marked, which are through sustainable forestry at every level. Every retail person also has to manage and keep them separately, those which are grown through the sustainable forestry. And accordingly, the final consumer will be known how exactly these are sustainable. So the energetic performance also, I think, at every level has to be very clearly evident how this is managed. So that is when the supply chain can be effective. And sustainability there is, because we call what is called as a life cycle, or it is not, it's a very, very vast thing. To manage it is something that, for example, when we are talking of a material, the material means that extraction, the life cycle of a material starts from extraction up to the demolition. So at every level, there is energy consumption. So we talk of these embodied energies. When we talk of that, that means what is the actual energy that finally, when you receive it, what is the total amount of energy that has gone into it? So there are data for this. There is a lot of embodied energy, but of course, there is still big scope for research in this area. But there are data, and it is possible for us to understand what is the thing that's coming, the product that is coming to you, or the material that is coming to, what is its energetic performance through the entire, the supply itself. That there is a considerable amount of data that is available today. Of course, we should be researching, and we should be, because I also think, see, when we talk of embodied energy, for example, we also integrate the transport component, transport to site, but every site has a different thing. So maybe, you have somewhere in the vicinity a supply, a retailer who's supplying. So there, for example, that component reduces in your site for your material. Whereas for some other material X, which is 500 kilometers away, maybe it is altogether different. So I think it is important that the supply chain, we have to do more and more studies. We have to have a lot more, every context, every local group should have what is the, the component of what are the right materials, what are most sustainable, what are the smart materials for that particular region. There have to be some kind of, such guidelines. If they are available, it is so much easier to manage. Yes, that is true.
Thank you very much, ma'am. It was a nice and wonderful presentation, and it has really enlightened us to the building of a smart city project. It has shown us how to go about the building of a smart city project, the various technicalities, and the various opportunities on various sectors. So thank you very much again from the side of the organizers.
Yeah.
Thank you to the participants as well. This is the end of the day 4 of the faculty development program on role of energy management in smart city. I will be sharing the feedback link shortly, within half an hour, in the WhatsApp group. We hope to see you again, all the participants, tomorrow at 11 a.m. Thank you all. Thank you very much. Good night.
Thank you.